The United States Naval Research Laboratory is the corporate research laboratory for the United States Navy and the United States Marine Corps, and conducts a wide range of basic scientific research, applied research, technological development and prototyping. A few of the laboratory's current specialties include plasma physics, space physics, materials science, and tactical electronic warfare. NRL is one of the first U.S. government scientific R&amp laboratories, having opened in 1923 at the instigation of Thomas Edison, and is currently under the Office of Naval Research. NRL's research expenditures are approximately $1.1 billion per year. Research. The Naval Research Laboratory conducts a wide variety of basic and scientific research and technological development of importance to the Navy. It has a long history of scientific breakthroughs and technological achievements dating back to its foundation in 1923. In many instances, the laboratory's contributions to military technology are declassified decades after those technologies have become widely adopted. In 2011, NRL researchers published 1,398 unclassified scientific and AMP technical articles, book chapters and conference proceedings. In 2008, the NRL was ranked number 3 among all U.S. institutions holding nanotechnology-related patents, behind IBM and the University of California. Current areas of research at NRL include advanced radio, optical and infrared sensors, autonomous systems, computer science and artificial intelligence, directed energy technology, electronic electro-optical device technology, electronic warfare, enhanced maintainability, reliability and survivability technology, environmental effects on naval systems, imaging research and systems, information technology, marine geosciences, materials, meteorology, ocean acoustics, oceanography, space systems and technology, surveillance and sensor technology, undersea technology, among a wide range of other specific topics and technologies. NRL is currently researching armor for munitions in transport, high-powered lasers, remote explosives detection, spintronics, the dynamics of explosive gas mixtures, electromagnetic railgun technology, detection of hidden nuclear materials, graphene devices, high-power extremely high-frequency amplifiers, acoustic lensing, information-rich orbital coastline mapping, Arctic weather forecasting, global aerosol analysis and AMP prediction, high-density plasmas, millisecond pulsars, broadband laser data links, virtual mission operation centers, battery technology, photonic crystals, carbon nanotube electronics, electronic sensors, mechanical nanoresonators, solid-state chemical sensors, organic optoelectronics, neural electronic interfaces and self-assembling nanostructures. The laboratory houses a wide range of R&amp facilities. The most recent additions include the NRL Nanoscience Institute's 5000 SQFD Class 100 nanofabrication cleanroom and quiet measurement labs, and the Laboratory for Autonomous Systems Research. Notable accomplishments. Space sciences. The Naval Research Laboratory has been a crucial piece of the United States space program. Project Vanguard, the first American satellite program, tasked NRL with the design, construction and launch of an artificial satellite, which was accomplished in 1958. The Vanguard I, designed and built at NRL, was the first solar-powered satellite. As of 2013, Vanguard I is still in orbit, making it the longest-lived man-made satellite. The Vanguard II was the first satellite to observe the Earth's cloud cover and therefore the first meteorological satellite. NRL pioneered the study of the Sun ultraviolet and X-ray spectrum. Along with Project Vanguard, NRL also designed the first satellite tracking system, Minitrack, which became the prototype for future satellite tracking networks. NRL's recently declassified Galactic Radiation and Background I was the first U.S. intelligence satellite intercepting Soviet radio communications from space. The Global Positioning System was invented at NRL and tested by NRL prototype satellites Dimation I and Dimation II in 1967 and 1969, and the first operational GPS satellite, Dimation IV, was designed and constructed at NRL. The Marine Meteorology Division produces satellite imagery and forecast models of worldwide weather and makes publicly available imagery from 18 weather imaging satellites. NRL's spacecraft development program continues today with the TACS-84 Experimental Tactical Reconnaissance and R&amp communications satellite. In addition to spacecraft design, NRL also designs and operates research instruments, such as the Large Angle and Spectrometric Coronagraph experiment aboard the Solar and Heliospheric Observatory. NASA's Gamma Ray Large Area Space Telescope was tested at NRL spacecraft testing facilities. NRL scientists have most recently contributed leading research to the study of novas and gamma-ray bursts. Materials science. NRL has a long history of contributions to materials science, dating back to the use of industrial radiography with gamma rays for the non-destructive inspection of metal casings and welds on Navy vessels. Beginning in the 1920s, modern mechanical fracture mechanics were pioneered at NRL and were subsequently applied to solve fracture problems in Navy vessels, commercial aircraft and Polaris missiles. The knowledge is in widespread use today in applications ranging from design of nuclear reactors to aircraft, submarines and toxic material storage tanks. NRL developed the synthesis of high-purity gallium-3 arsenide crystals used in a myriad of modern high-frequency transceivers including cellular phones, satellite communication systems, commercial and military radar systems including those aboard all U.S. combat aircraft and ARM Phoenix, AIM-9L and AMRAAM missiles. NRL's gallium-3 arsenide inventions were licensed by Rockwell, Westinghouse, Texas Instruments and Hughes Research. High-purity gallium-3 arsenide is also used for high-efficiency solar cells like those aboard NASA's Spirit and Opportunity rovers currently on Mars. Fundamental aspects of stealth technology were developed at NRL, including the radar absorption mechanisms in ferrite-containing materials, metal-bearing surface treatments using CR-ion implantation. Researched at NRL nearly tripled the service life of Navy turbine engine parts and was adopted for Army helicopter parts as well. Fluorinated polyurethane coatings developed at NRL are used to line fuel storage tanks throughout the U.S. Navy, reducing leakage and environmental and fuel contamination. The same polymer films are used in Los Angeles-class submarine radomes to repel water and enable radar operations soon after surfacing. Scientists at NRL frequently contribute theoretical and experimental research on novel materials, particularly magnetic materials and nanomaterials, electronic warfare and information security. The first modern U.S. radar was invented and developed at NRL in 1922. By 1939, NRL installed the first operational radar aboard the USS New York, in time for radar to contribute to naval victories at the Coral Sea, Midway and Guadalcanal. NRL then further developed over-the-horizon radar as well as radar data displays. The laboratory is responsible for the identification, friend or foe system. The Information Technology Division has a world-class information security R&amp D group, which is where the IETF's IP security protocols were originally developed. The Encapsulating Security Payload Protocol developed at NRL is widely used for virtual private network connections worldwide. The projects developed by the laboratory often become mainstream applications without public awareness of the developer. An example in computer science is onion routing, the core principle of the anonymizing Tor software. Nuclear energy. Nuclear power research was initiated at NRL as early as 1939, 6 years before the first atomic bomb, for the purpose of powering submarines. Uranium enrichment methods sponsored by NRL over the course of World War II were adopted by the Manhattan Project and guided the design of Oak Ridge National Laboratory's uranium enrichment plant. NRL is currently developing laser focusing techniques aimed at inertial confinement fusion technology. Physical sciences. After World War II, the laboratory developed modern synthetic lubricants initially for use in the Navy's jet aircraft, but they were subsequently adopted by the commercial jet industry. In the late 1960s, NRL researched low-temperature physics, achieving for the first time a temperature within 1/1,000,000th of a degree of absolute zero in 1967. In 1985, two scientists at the laboratory, Herbert A. Hauptmann and Jerome Karl, won the Nobel Prize for devising direct methods employing X-ray diffraction analysis in the determination of crystal structures. The methods formed the basis for the computer packages used in pharmaceutical labs and research institutions worldwide for the analysis of more than 10,000 new substances each year. NRL has most recently published research on quantum computing, quantum dots, plasma shock waves, thermodynamics of liquids, modeling of oil spills and other topics. Organization. As of December 2013, NRL has 2,381 full-time employees, the majority being professional or technical scientists and engineers along with administrative staff, enlisted military officers and senior executives. Of permanent civilian employees, 31% have bachelor's degrees, 21% have master's degrees and 48% have a doctorate degree. The laboratory also hosts postdoctoral researchers and was voted number 15 in the Best Places to Work Postdocs 2013 survey. The laboratory is divided into 4 research directorates, 1 funding directorate, and 1 executive directorate. All the directorates are headquartered in Washington, D.C., and many have other facilities elsewhere. The 4 research directorates are: the Systems Directorate is responsible for performing a range of activities from basic research through engineering development to expand the operational capabilities of the U.S. Navy. There are 4 research divisions: Radar Information Technology, Optical Sciences, and Tactical Electronic Warfare. The Materials Science and Component Technology Directorate carries out a range of materials research with the aim of better understanding of the materials in order to develop improved and advanced materials for use by the U.S. Navy. There are 7 research divisions: Laboratory for the Structure of Matter, Chemistry, Material Science and AMP Technology, Laboratory for Computational Physics and Fluid Dynamics, Plasma Physics, Electronic Science and AMP Technology, and the Center for Biomolecular Science and AMP Engineering. The Ocean and Atmospheric Science and Technology Directorate performs research in the fields of acoustics, remote sensing, oceanography, marine geosciences, marine meteorology, and space science. There are 6 research divisions: acoustics, remote sensing, oceanography, marine geosciences, marine meteorology, and space science. The mission of the Naval Center for Space Technology is to preserve and enhance a strong space technology base and provide expert assistance in the development and acquisition of space systems for naval missions. There are 2 research divisions: Space Systems Development and Spacecraft Engineering. The 2 support directorates are: the Executive Directorate. Operations are directed by the commander of the NRL, who typically is a U.S. Navy captain. In addition to management functions, the Directorate also manages the Nanoscience Institute, founded in April 2001 as a multidisciplinary nanotechnology research institute at the intersections of the fields of materials, electronics and biology. Scientific Development Squadron 1, located at Naval Air Station Patuxent River, Maryland, which provides airborne research facilities to NRL as well as other agencies of the U.S. government, is also run out of the Executive Directorate. The Business Operations Directorate provides program management for the business programs which support the scientific directorates of NRL. It provides contracting, financial management and supply expertise to the scientific projects. Locations. The main campus of NRL is in Washington, D.C., near the southernmost part of the district. It is on the Potomac River and is immediately adjacent to Joint Base Anacostia Bowling. In addition, NRL operates several field sites and satellite facilities. NRL Stennis is located at NASA's Stennis Space Center in Bay Street, Louis, Mississippi, and specializes in oceanography, marine geology, geophysics, geoacoustics, and geotechnology. NRL Monterey is located east of the Naval Postgraduate School in Monterey, California, sharing a campus with the Fleet Numerical Meteorology and Oceanography Center and the San Francisco Bay Area Monterey Local Forecast Office of the National Weather Service. NRL Monterey is dedicated to atmospheric research. Scientific Development Squadron 1 is located at Naval Air Station Patuxent River in Maryland, and operates aircraft used as airborne research platforms. The Chesapeake Bay Detachment in Chesapeake Beach, Maryland is a 168-acre site for research in radar, electronic warfare, optical devices, materials, communications, and fire research. This facility is often used with the multiple research site on Tillman Island, Maryland, just across the Chesapeake Bay. The Midway Research Center in Quantico, Virginia, Free Space Antenna Range in Pamunkey, Maryland, and Blossom Point Satellite Tracking and Command Station in Blossom Point, Maryland are used by the Naval Center for Space Technology. The Marine Corrosion Facility located on Fleming Key at Naval Air Station Key West in Florida is used by the Center for Corrosion Science and AMP Engineering. The Exus Shadwell in Mobile Bay, Alabama is used by the Center for Safety and Survivability to develop and test techniques and equipment for shipboard firefighting. NRL operates several synchrotron radiation beamlines and the Extreme Ultraviolet and X-ray calibration facility at the National Synchrotron Light Source at the Brookhaven National Laboratory. History. Early history. Artifacts found on the NRL campus, such as stone tools and ceramic shards, show that the site had been inhabited since the late Archaic period. Cecil Calvert, 2nd Baron Baltimore, granted the tract of land including the present NRL campus to William Middleton in 1663. It became part of the District of Columbia in 1791, and was purchased by Thomas Edison in 1795, who named the area Bellevue and built a mansion on the highlands to the east. Zachariah Berry purchased the land in 1827, who rented it out for various purposes including a fishery at Blue Plains. The mansion was demolished during the Civil War to build Fort Greeble. In 1873 the land was purchased by the federal government as the Bellevue Annex to the Naval Gun Factory, and several buildings were constructed including the Commandant's House, Quarters, which is still in use today. Foundation. The Naval Research Laboratory came into existence from an idea that originated from Thomas Edison. In a May 1915 editorial piece in the New York Times Magazine, Edison wrote, "The government should maintain a great research laboratory. In this could be developed all the technique of military and naval progression without any vast expense." Quote, this statement addressed concerns about World War I in the United States. Edison then agreed to serve as the head of the Naval Consulting Board that consisted of civilians who had achieved expertise. The focus of the Naval Consulting Board was as advisor to the U.S. Navy pertaining to science and technology. The board brought forward a plan to create a modern facility for the Navy. In 1916, Congress allocated $1.5 million for implementation. However, construction was delayed until 1920 because of the war and internal disagreements within the board. The U.S. Naval Research Laboratory, the first modern research institution created within the United States Navy, began operations at 1100 on the 2nd of July 1923. The laboratory's two original divisions, radio and sound, performed research in the fields of high-frequency radio and underwater sound propagation. They produced communications equipment, direction-finding devices, sonar sets, and perhaps most significant of all, the first practical radar equipment built in the United States. They performed basic research, participating, for example, in the discovery and early exploration of the ionosphere. Moreover, the NRL was able to work gradually toward its goal of becoming a broadly based research facility. By the beginning of World War II, 5 new divisions had been added: physical optics, chemistry, metallurgy, mechanics and electricity, and internal communications. World War II years and growth. Total employment at the NRL jumped from 396 in 1941 to 4,400 in 1946. Expenditures from $1.7 million to $13.7 million. The number of buildings from 23 to 67, and the number of projects from 200 to about 900. During World War II, scientific activities necessarily were concentrated almost entirely on applied research. New electronics equipment, radio, radar, sonar, was developed. Countermeasures were devised. New lubricants were produced, as were anti-fouling paints, luminous identification tapes, and a sea mark to help save survivors of disasters at sea. A thermal diffusion process was conceived and used to supply some of the U-235 isotope needed for one of the first atomic bombs. Also, many new devices that developed from booming wartime industry were type-tested and then certified as reliable for the fleet. Since World War II, as a result of the scientific accomplishments of the war years, the United States emerged into the post-war era determined to consolidate its wartime gains in science and technology and to preserve the working relationship between its armed forces and the scientific community. While the Navy was establishing the Office of Naval Research as a liaison with and supporter of basic and applied scientific research, the Navy encouraged NRL to broaden its scope since it was the Navy Department's corporate research laboratory. NRL was placed under the administrative oversight of ONR after ONR was created, a parallel shift of the laboratory's research emphasis to one of long-range basic and applied investigation in a broad range of the physical sciences. However, rapid expansion during the war had left NRL improperly structured to address long-term Navy requirements. One major task, neither easily nor rapidly accomplished, was that of reshaping and coordinating research. This was achieved by transforming a group of largely autonomous scientific divisions into a unified institution with a clear mission and a fully coordinated research program. The first attempt at reorganization vested power in an executive committee composed of all the division superintendents. This committee was impracticably large, so in 1949, a civilian director of research was named and given full authority over the program. Positions for associate directors were added in 1954. In 1992, the previously separate Naval Oceanographic and Atmospheric Research Laboratory, with centers in Bay Street, Louis, Mississippi, and Monterey, California, was merged into NRL. NRL now is additionally the lead Navy Center for Research in Ocean and Atmospheric Sciences, with special strengths in physical oceanography, marine geosciences, ocean acoustics, marine meteorology, and remote oceanic and atmospheric sensing.